To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello dear grade 7 children. Today we are going to learn the 14th lesson of the science textbook, that is heat and temperature. Now when we go through this topic, heat and temperature, are they the same thing or heat and temperature are two different things? Now we have a feeling that heat and temperature are the same thing. Right, children? But under this lesson, we are going to learn that heat and temperature, even though they feel like the same thing, but they are two different things. Okay, children? So under this lesson, we are going to learn many information about heat and temperature. So let's see what are the topics that we are going to learn under this lesson. So we are going to learn this lesson under 4 topics. What are the topics, children? Measuring temperature. Here we are going to learn how to measure temperature correctly, right? And the second topic, we are going to learn about thermometers, right, children? And the third topic, we are going to learn about heat transfer. So under heat transfer, we are going to learn that heat travels from one place to another place by 3 methods, right, children? So we are going to learn about those 3 methods under this topic. Application of convectional currents. So under this one, we are going to specifically learn about one method of heat, the traveling of heat from one place to another place, and how to apply these convectional currents, this method in daily life. Right, children? So we are going to start this lesson now. So the first topic is measuring temperature. Okay, we'll go through this one. The environment becomes warm during the daytime due to the solar heat and gets cool at night. Now, do you remember we learned a similar lesson in grade 6? This lesson was called the effects of heat. So under that one, we learned that by absorbing heat, objects increase their temperature. Right, children? So the environment becomes warm during the daytime due to the solar heat and gets cool at night. So during the daytime, what happens? Because of the sun's heat, because of the solar energy, the sun's heat is absorbed by the things in the environment, right? By the soil, by the plants, by the rocks and all, and the water bodies, etc. So when heat is absorbed, what happens, children? Because of the absorption of heat, the temperature increases. Okay, so by absorbing heat, temperature increases. Normally we don't say by absorbing heat, heat increases. When heat is absorbed, temperature is increased. What is heat? Heat is a type of energy. Heat energy, or another name is thermal energy. In the 7th lesson, we learned how thermal energy, this heat energy, can be used to do our day-to-day activities. Right, children? So by absorbing the heat of the sun, what happens? The environment becomes warm, or the temperature increases. Right, children? During the night time, what happens, children? There's no sunlight, therefore, there's no way for the objects to get warmed up, to heat it up. The environment, then what happens? During the daytime, the environment gets heated up. During the night time, the environmental temperature becomes less. In that case, heat in this object is given out to the environment. Right, children? So let's say that if there's a heated rock, during the daytime, because the sunlight present, this rock absorbs the heat from the sun and gets heated up, right? Increases its temperature. During the night time, what happens, children? There's no sunlight, therefore, the environmental temperature is less. Now here, in this object, in this rock, it is already warmed up, therefore what happens? At one time, this one's heat is higher than that of the temperature of the atmosphere. In that case, this heat is given out to the environment. So this rock releases its heat. During the daytime, when the environment gets heated up, this rock absorbs heat from the environment. Right? During the night time, environmental temperature is lower than the object. Then the object releases heat from its environment. So you can get an idea how this heat travels from one place to another place. Heat always travels from where it is higher to lower. During the daytime, outside temperature is higher, therefore heat is absorbed by the rock from outside to inside, from where it is higher to lower. So during the night time, outside the temperature is lower than this object. Then what happens? The heat of this object is given out. Heat travels from the object to the environment, where it is higher to the lower place. Right, children? Warmness and coldness are two sensations that we feel. Right, children? Warmness and coldness are two sensations that we feel. Right? When the outside environment is very high, we say that it's very warm. Right? During the night time, when the environmental temperature is lower, we call that it's very cold. Right, children? So when you are in areas like Colombo, Jaffna, the environment is usually warmer. When we go to areas like Nuwara, the temperature decreases and therefore normally the environment is colder. Right, children? So this warmness and coldness are two sensations that we feel. Warmness and coldness. Right, children? So we have this activity to do, finding out more about warmness and coldness. So what do we need? We need two vessels of water. One should be filled with warm water, lukewarm water, not very warm, right? Lukewarm water. And the other one should be filled with cold water. Lukewarm water and cold water. Right? We have to take two similar vessels. Right, children? So how to do this activity? Method. Get equal amounts of lukewarm water and cold water into two beakers of the same size. This beaker or the vessel should be big enough so that we can insert our hands. You can see the diagram. Dip your fingers into the water of the beakers at the same time. We have to do this. Right now, I'm not going to do this activity. You have to do this activity at home. Even if I do this activity, you can't see any observation because that is something I can feel. Right? The person who is doing this activity can feel this, can see the observations. Therefore, I'm not going to do this activity. This activity can be done by you all very easily at home. Right? So dip your fingers into the water of the beakers. So then what happens? Record what you feel. What would you feel? Even without doing this one, we know that what happens. Right? At the same time, when you immerse your two hands in these two beakers with two different types of water, one is warmer than the other one, you will feel the warmness to one hand and you will feel the coldness to the other hand. You can see the temperature. You can feel the difference of this temperature. Right, children? Okay. So we'll see. You may feel that the water's warmth is different in two beakers. What is the difference between cold water and lukewarm water? Water was heated on a hearth or on a burner. Then the water was warmed by receiving thermal or heat energy. So when we heat something, when we provide heat to a certain object, it absorbs heat. Right, children? It absorbs heat. Therefore, its temperature increases. So heat and temperature are two different things. Heat is a type of energy. Right? The measurement of the warmness or coldness of a substance is known as its temperature. So how much heat energies contained in a certain object is measured by using the measurement called temperature. Heat is the type of energy contained in a certain object. That heat can be measured using temperature. So we don't say measure the heat, we say measure the temperature, right? But we can get an idea of the amount of heat present in a certain object by measuring its temperature. They are very related, but at the same time they are different, right? They are related to each other, but these two terms are different from each other too. The measurement of the warmness or coldness of a substance is known as its temperature. You can use temperature to measure the amount of heat. Right, children? And heat always travels from where it is higher to lower. Right, children? Okay. So this extra knowledge part is also there. We'll go through this. We feel warm when a heated object is being touched, because heat transfers from that object to our hand. Right? Let's say that if there's a heated kettle, when we touch this kettle, what will happen? When we touch this kettle, what happens, children? This one's temperature is higher than our hand. More heat energy is contained in this kettle than our hand. So the heat travels from one place to another place where it is higher to lower. So heat transfers from the kettle to our hand. Right? So we feel it's warmer. Its warmness we can feel. We feel warm when heated object is being touched, because that heat transfers from that object to our hand. That the particular place of our hand in contact with the kettle, right, this hot water kettle, we feel that place is warmer than the other places. That's a certain sensation. Next one. Coldness is felt when a piece of ice is touched. When we place a piece of ice on our palm, we feel that place on our palm is cold. Right? What is this? Because heat transfers from our hand to the piece of ice. Very interesting, right? So, when you place a piece of ice in your hand, what happens? If this is the piece of ice, what happens, children? What happens? The temperature of your hand, there's more heat present in your hand than that of ice. Therefore, from this particular place, heat transfers from your hand to the ice cube this time. From where it is higher to lower. When you consider the first instance, temperature or heat is higher here in the kettle, lower in your hand. But when you consider this incidence, the heat is higher in your hand than that of the ice cube. Therefore, heat travels from where it is higher to lower, from your hand to the piece of ice. Right? Because of drop of heat, because of releasing heat from that particular place of your hand, because of loss of heat from that particular place, you feel that place is colder than the other places of your body. Right? The sensation is known as coldness. So coldness is felt when a piece of ice is touched, because heat transfers from our hand to the piece of ice. Right, children? So after doing these activities, it's clear that heat transfers from where it is higher to lower. And heat and temperature are two different things, even though they are related. We'll move on to the next. We have another activity to do, finding out how to measure temperature correctly. What we have to do this, first of all, we have materials. We need 2 empty glass bottles of the same size and 2 rubber stoppers, 2 empty pen tubes of the same size, and 2 beakers of the same size, and water and ink. So here in this experiment, we are going to use colored water, right? We will write this first. Two small glass bottles. You can even use test tubes, okay? 2 rubber stoppers. 2 rubber stoppers. 2 empty pen tubes. 2 beakers. And we need water and ink. You can use just any color. 2 small glass bottles, 2 rubber stoppers, 2 empty pen tubes, 2 beakers, water, ink. Right? So how to do this activity? Let's see. Look at the setup. Right? Fill the small glass bottles with colored water. Look at these 2 bottles. It's filled with colored water. And fix the empty tubes of ballpoint pens. Right? Through the rubber stoppers, you have to fix the 2 empty pen tubes to these bottles. Right? So when you do this, you will realize the water, the colored water will enter this empty pen tube and it will stop at one place. You have to mark this level. Right? You have to mark this level. So initially, both the levels will be the same as you use similar glass bottles, similar rubber stoppers and similar empty pen tubes. Okay? So fill the small glass bottles with colored water and fix the empty tubes of ballpoint pens. Okay? Keep one of those bottles in a beaker filled with warm water and the other in a beaker filled with cold water. This is the difference here. One of these bottles should be immersed in warm water beaker. The other one should be immersed in cold water. Right? Observe what happens here. You have to observe. First of all, you have to mark the initial level of this colored water inside the empty pen tube. So when you immerse these 2 setups in warm water and cold water separately, you have to observe what happens to this level of this colored water inside the pen tube. Right? Whether the level remains the same, whether the level increases or decreases. Right, children? So you have to carefully observe the water level or inside this pen tube. This is the reason, in order to observe this clearly, we have to use the colored water. Okay, children, if you use just normal water, you can't observe it very clearly as it's colorless. So when you use the colored water, even though when these water level inside the pen tubes move up or down, or even though whether it's not going to move anywhere, we can observe it very clearly. Right, children? So we are going to do this activity now in the lab. Right, children? By doing this activity, we can understand how thermometers work. Look what I have here. Here I have 2 test tubes filled with colored water, and you all can see they are similar test tubes. You can even use small glass bottles, okay? And you all can see I have fixed 2 rubber stoppers here to cover the mouths of these 2 test tubes, and I have passed 2 empty pen tubes through these rubber stoppers. Right, children? And you all can see now it's filled with blue colored water. You all can see inside these empty pen tubes, water level is marked in black color. Can you all see? Right? Level of water is marked in the empty pen tubes. Now what I am going to do is, one of these test tubes I am going to immerse in warm water and the other one I am going to immerse in cold water. We are going to observe very carefully what happens to the water levels inside the empty pen tubes, right? And now at the same time I am going to pour. Now this is hot water, this is cold water, right? Observe carefully what happens to the water levels, children. You all can see already in this warm water beaker, the water level inside the pen tube increases than the level it was before. And here, in the cold water beaker, you all can see very clearly the water level goes down. Okay? Here the water level increases, here the water level goes down. I'm sure you know the reason for this, children, because we have learned the reason even before. Even in grade 6, we have learned the reason. Okay? So it's very clear. Inside the warm water beaker, what happens? The water level in the pen tube rises, goes up. And in the cold water beaker, what happens to the water level in the empty pen tube? It goes down than the level we marked before, right? What is the reason for this, children? You all know when the temperature increases in a certain setup. Now here what happens? This test tube, water inside the test tube absorbs the heat in this warm water, right? When heat is absorbed by a certain setup, a liquid or solid or gas, what happens to the volume, children? The volume increases. This is known as expansion. Right, children? The increase of volume due to absorption of heat is known as expansion. So what happens? The water level inside the test tube expands. The volume increases. So inside this test tube, there's no more space for the increased amount of water, increased level. Therefore, what happens? It goes through the empty pen tube. Now you all can see it has gone to the top. Right, children? Here what happens? Because of reducing the heat, now here we use cold water, the heat reduces. Therefore, what happens? Because of reduction of heat, contraction takes place. Here expands, here the opposite, contraction takes place, which means the volume reduces, decreases. When the volume decreases, what happens? Because the level of water goes down, you all can see it is below the mark that we already marked. Okay, children? So a similar theory is used in making the thermometers too. So we are going to learn about the thermometers. So thermometers has a certain bulb that is filled with a liquid, right? So because of expansion of contraction of the liquid according to different temperatures, we can measure the temperature of a certain setup using the thermometers too. Right, children? So you all observed what happened. Now this activity you all can do even at home, right? So even though you don't have the exact same things, beakers or any other laboratory equipment, with whatever you can find, you can make these two setups and you can do this activity even at home. Okay, children? So what did you observe? What did we do here? We used 2 empty bottles and we fixed these empty pen tubes, and first of all we fill these empty bottles with colored water and we fix these empty pen tubes to them, and one bottle we immersed in warm water, the other one in cold water. So then what happened, children? What happened to these water levels inside the empty pen tubes? We earlier marked the levels of it. Then what you have to do is you have to observe after immersing in each water vessels. And we clearly observe that this one we will consider this is A with warm water B. Setup A, the water level of the pen tube in setup A, what happens, children? It rises up, it increases. Right? What happened here, children? Here the water level goes down. When we immerse this colored water bottle in cold water, the water level inside the pen tube goes down. What is the reason for this, children? Here what happens, even in grade 6 you have learned this. By absorbing heat, what happens to the volume of liquids? The volume of the liquid increases. Right? When heat is supplied, the liquids and all the other matter, they absorb heat. And the size or the volume of the matter increases. So here we use the liquid. What happens? Warm water. The temperature of the water is higher than that of the colored water. So the heat travels from where it is higher to lower. Right? Heat travels from where it is higher to lower, which means this colored water absorbs heat. Right, children? Colored water absorbs heat. When the colored water absorbs heat, what happens? Its volume increases, and this is known as expansion. So by absorbing heat, the volume of the colored water increases, so it expands. When the volume increases, there's nowhere. Now here inside the bottle, as it is sealed with this rubber stopper, is there any other space? As the entire amount of bottle is initially filled with the water, is there any other place that water can go? No. The only way that water can increase its volume is through this empty pen tube. Therefore, the water level inside the empty pen tube goes up. Here what happens? You all know last year we learned that when heat is released from certain objects, their volume or the size decreases. This is known as contraction. So when you compare the temperature of this colored water and outside water, this one is warmer. This one has more heat. The colored water has more heat. So heat always travels from where it is higher to lower. So this time what happens? Heat travels from inside to outside. Heat travels from inside to outside. So then what happens to this colored water? It cools down. Colored water cools down because of reduction of temperature. What happens? Its volume decreases, and this is known as contraction. When the volume decreases, inside the bottle, it will get a little more space for more water, so that water present already inside this pen tube will go down, right? Because of reduction of volume. Right, children? So after doing this activity, it's very clear what happens, how heat travels, and what happens to liquids when we provide heat and when heat is released. Okay, let's write this observation. Colored water level of the pen tube. Colored water level of the pen tube fixed to the bottle immersed in warm water rises up. Colored water level of the pen tube fixed to the bottle that is immersed in cold water falls down or drops. Right? Colored water level of the pen tube fixed to the bottle that is immersed in warm water rises up. Right? Colored water rises up. Colored water level rises up here. Here, colored water level of the pen tube fixed to the bottle that is immersed in cold water falls down. So here, the colored water level falls down. Now we learn the reason for this also. We will write the conclusion. Here I label them as A and B. In setup A, colored water expands, which means volume increases. due to absorption of heat. In setup B, colored water cools down and contracts. Contracts means volume decreases. Right, children? In setup A, colored water expands, so volume increases due to absorption of heat. In setup B, colored water cools down and contracts, or volume decreases. Right, children? Here the same thing is explained. The liquid column in tube of the bottle kept in warm water rises up. The liquid column in the tube of the bottle kept in cold water falls down. Accordingly, heat transfers from warm water in the beaker to the water in the bottle. Then the volume of water in the bottle increases to rise up along the tube. It's in the first setup. Water in bottle kept in beak of cold water cools to decrease the volume or contracts. Then the liquid column in the tube of that bottle falls down. Right, children? So this incident is known as expansion. Increase in the volume is known as expansion. Decrease in the volume is known as contraction. An increase in the volume of a liquid by gaining heat is called the expansion of the liquid. Right? It is the property of expansion of a liquid that is used in making thermometers. Now next we are going to learn about thermometers. This property of expansion is used in making thermometers. Right, children? Making thermometers. It is the property of expansion of a liquid that is used in making thermometers, because when we make thermometers, a liquid is used. Right, in bulb thermometers, we are going to learn about the bulb thermometers. So when we make bulb thermometers, a liquid is used to fill the bulb. This liquid expands and we can get the reading. Okay, children? So we have completed the first chapter of this lesson. So in this chapter, we learn about the difference between heat and temperature, and warmness and coldness too. Okay, and we did experiments to learn about this expansion of liquids, what happens due to absorption of heat by liquids. Now we know several information about heat and temperature. So about the other information we are going to learn in the next chapters.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.